Hello, everybody. Welcome. Hope we've got a lot of people from Superset land here today and a whole bunch of people from Preset. We're excited to talk about a whole bunch of things that are happening in the, I guess past, present, and future of semantic layers in Superset, which very much affects Preset as well. So we'll get right into this. You've probably seen me at one of these before. If you have, hello again. My name is Evan. If this is the first time coming to one of these, then I work for Preset as a developer advocate. I work in the Superset community as a PMC member and just kind of sweeping up things on GitHub. So you've probably seen me around making lots of noise and stuff. And then our illustrious guest today is Beto.
Yeah, I'm Beto. I used to work for Preset, switched jobs recently. I've been working with Superset for 9 years now, 3 years at Lyft, 6 years at Preset, and I'm really excited to do this talk because I think there's a lot to gain from the semantic layers integration, especially with AI. I'll pass it to Elizabeth.
Yeah, hi everyone. I'm Elizabeth. I'm Director of Engineering at Preset and also an Apache Superset PMC member. And I have the great pleasure of working with these two folks.
So today we want to get into everything that's happening in semantic layers, especially section 3 that's highlighted there, where we'll go into Beto's work on the SIP or superset improvement proposal that enables all of this stuff that's happening now. But first, we'll go into a little bit about why semantic layers exist. And then after we go through some little bit technical stuff about how semantic layers are getting wired up into superset now, we'll talk about the future and what it holds, all of the possibilities around Apache Ossie, which is a new top-level project of the foundation, and of course, how you can get involved, possibly the most important part of open source projects. All right, so semantic layers, what are they for? Well, this is a common scenario in analytics, right? We all have it. What is a customer? What is a sale? What is, you name your business question and ask anyone in the company, you're going to get different answers. Metrics and dimensions and all of these things tend to be defined from multiple lenses, and you get, depending on how you query things, how your data warehouse is all put together, you're going to get possibly different answers. Now, that problem used to be kind of hand waveable a little bit, depending on your tolerance level. But now that we're all using AI and MCP tools and things, the problem compounds because the LLMs are just going to go ahead and pick one of these metrics at random. And suddenly you don't know the provenance of this information and you can't trust it. And, the last thing you want in any analytics tool is trust issues. So suddenly having a proper source of truth for every metric is really one of the most valuable things, one of the biggest problems we should be solving. And this SIP that Beto wrote, there's a QR code to it. There's a couple QR codes in here if you want to scan them. You'll talk about it in great detail, but I guess the point of it is that we have this new explorable interface that replaces the way we used to think about data sets in Superset. Like Superset has always had a semantic layer. We know it as the dataset editor, but now we've got a path forward to extract that, which we'll talk more about, as well as adding other semantic layer projects and products to your data stack.
Yeah, I think this speaks a little bit to why semantic layers are needed also in the original semantic layer for Superset. Usually, like when we talk about metrics, dimensions, like the definition varies. There's also measures, but in Superset world, when we talk about metric, we're talking about an aggregation. So usually you have a fact table and you're doing some kind of count. This can be super simple. It can be a count star. If you have a table with orders, you want to see how many orders you had, you can do a count star. And it can get really complex. It can be any aggregation. For Superset, a metric is an aggregation expression. So if you need to add filters, you can't add it on the where. You need to use a case when, and you can kind of like jam a filter predicate in the expression. And when we talk about dimensions, it's usually a related column that you can bring in usually with the join. It usually has low cardinality. So you can think of like a user country or age bucket. if you have a lot of IDs, you don't want to use user ID as a dimension just because your metrics are going to explode. And this goes back to what Evan was saying, like, why do we need semantic layers, right? There's a lot of knowledge that is tribal knowledge. Like if you're looking at how many users you have, you might get different results. And then, an analyst might say, oh, but in that table, you need to exclude user ID 42 because that was a test we ran, so you shouldn't count that. So there's a lot of knowledge that doesn't live in your database, in your warehouse. It's not in your tables. And the semantic layer is a way of formalizing that knowledge in some kind of system that hopefully becomes the source of truth for all your BI tools, your reporting, your dashboards, so that that knowledge is formalized. And of course, this will help agents a lot, because an agent looking at your database would not have that context. It would have to scan Slack and emails and groups to get that same knowledge that is easy to formalize.
Yeah. And I guess you could tell us a little bit here about how this always has been handled in Superset.
Yeah, we've been talking about semantic layers. Like Superset always had a semantic layer. It's a thin semantic layer. It was there from the start because Superset started as a front end to Druid in a time where Apache Druid, it didn't have a SQL interface. You would do JSON requests. So writing queries was complicated. So you define your metrics, you say which ones are filterable, groupable, because Druid was really bad if you did a group by on a high cardinality column. So we had to consolidate that knowledge somewhere. So we created, okay, let's create a data set. Instead of the user querying tables, we have a little bit of safeguards, and then you can define metrics, you can define calculated columns. And as we added support for SQL to Superset, the representation became SQL. And if you go to the next slide, I talk a little bit about bringing in dimensions. This is something that I think a lot of Superset users ask for, at least I've seen. You're exploring some kind of table, you're creating a chart, and you're like, oh, I really wish I could break this down, by device. Is this metric going down on iOS? Is it an Android thing? Is it like desktop, right? You want to do some breakdown, and you say, I really wish I could bring in a dimension so that I can get more knowledge out of what I'm seeing, right? And then there's basically like two schools of thoughts of how you bring in dimensions. So for Superset, it's at compile time, we can say. When you define your data set, you bring everything you want, and it's really hard to go back, right? So you need to either have a denormalized table, a very wide table with all the dimensions, and you explore that, or you need to go to SQL Lab, write a join to bring in the dimensions you want, and then explore the virtual data set. But the issue here is if it requires planning, right? You need to think ahead, like, okay, you need to think, okay, maybe I'm going to bring these dimensions because I might need them, but that has a cost. So it's more rigid and requires planning. The pros is it's fast. Your data is denormalized. If it's a virtual data set, we can assume that the join is an efficient join. The person who wrote the join knew what they were doing. So it's going to be faster. And then we have some other semantic layers. They can bring in dimensions at runtime. So they have this information about dimensions relationships. But sometimes that can live in the database, right? You can have foreign keys, but sometimes it's a more subtle relationship that needs to live in the semantic layer. And you can bring those at runtime. So if you look at a metric and you're like, I want to break it down by gender, you can just bring it, and the semantic layer engine will know how to do the join for you. So it's a trade-off between flexibility and speed, right? At runtime, that join might not be efficient, depending on if you're going through a many-to-many relationship, you might have incorrect metrics, you might have like an explosion of the cardinality. So it's potentially inefficient. And this is the architecture of semantic layers. Like before the work I did on SIP 182, we have explore, right? And we have the database at the bottom, and we need some kind of semantic layer, which is the data set, to allows us to explore that data and build charts, right? So we can have physical data sets, virtual data sets, and the way this works, if you're not familiar with, basically Explore will like inspect what columns are there, what metrics are there in the data set, and then emit SQL. That SQL gets sent to the database, and then we create charts. This works really well for databases with some caveats there. One of the problems here is like we are emitting SQL, and that SQL is very complicated. Superset supports more than 50 different databases. There's dozens of different dialects. And then when you're building the SQL based on your semantic layer, the data set, it can get really complicated. Some databases, they don't support aliases in the order by or aliases in the group by. The way we do time grains is different for each database, right? So generating that SQL is done in a function that has like 700 lines of code. It's really complex, and there's a lot of dependencies on the DB engine specs, and they contain the intricacies of each database. The problem compounds once we started to try to connect Superset to semantic layers that were external, right? This has been a push. People are using, like Airbnb, they use Minerva, it's their in-house semantic layer. At Preset, we've been integrating it with dbt and then later MetricFlow. I did an integration with Snowflake last year that was like this. I did integration with Data Junction, which is another open source semantic layer. And the problem here is like, Superset connects to databases, right? If you want to connect it to a semantic layer, you might think, okay, let's pretend that the semantic layer is a database, right? Let's create the pseudo-database, and then we have these like data sets that point to pseudo-tables in the pseudo-database, and now we're going to emit SQL, and then we're going to take that SQL and translate it into something that the semantic layer understands. If you're not scared of how brittle all of this is, I can talk a little bit, like we're generating SQL, right? We need to parse that SQL, translate it into REST requests or GraphQL requests, depending on the semantic layer. So it starts to get really brittle. That SQL that was already very complicated, now we need to parse it and generate different requests. And there's also a problem of leaky abstractions. Like we have a semantic layer external, and now we're mounting it as a database, and then we put the superset semantic layer on top of it. So we have a semantic layer on top of a semantic layer. What happens if you define a metric in the data set? How does that translate? Usually it doesn't, right? So it was a very like brittle and hacky approach, which is why we decided to support semantic layers as like a first class data connection. So we're changing database connections to be data connections, and then you have databases, you have semantic layers like as siblings, the same hierarchy. The first thing I did was clean up a little bit the abstractions, right? So we don't want to generate SQL, we don't want to parse SQL, right? So what I did is Explore sends a payload request called the query object, and I simplified the interface, created the Explorable from the Explore mixin, which was an initial work by Hugh Miles did to support queries in Explore, right? Before you could only create charts from data sets. At some point, we decided that we want to create charts directly from queries. So we created the Explore mixin, but that was very tied to the SQL Alchemy models. So I created a pure protocol called Explorable, which is like, okay, this is what we need to support in order to create a chart out of something. So then we have datasets, queries, and now we have semantic views. Semantic views are the dataset equivalent of a semantic layer. There are many different names. DBT called them models, Cube called them cubes, and Snowflake calls them semantic views. We went with semantic views because there's a nice parity there with semantic layer, semantic view. So this works great for anything with some caveats. The problem with this is that the query object is a very complex beast. On the far right there's one query object that I defined. Query object is an internal object that we have at Superset that captures the request coming to create a chart. It has 29 fields. One of them is called extras, which is a dictionary with 7 fields. There's filters everywhere. There's filters, there's extras, has having, has where. There's from datetime, there's inner from datetime. Like it is very complicated. It evolved organically over the time. And when I was working on this, I didn't want to tell developers we're going to integrate new semantic layers to Superset to like, hey, you need to figure this out, right? You're going to implement a new semantic layer. It's easy, just take the query object and give me a query result, right? That's unfair with developers, I think. So the second thing I did was creating a mapper function that takes the query object, you can see it on the left, and it translates into a semantic query object, which is a very simplified, very semantic request, right? Because like imagine you're a developer, you want to integrate your semantic layer to superset. What's the difference between from datetime and inner from the datetime? Why do we have filters and then we have more filters inside the extras? What's the difference between a time shift and a time offset, right? Why does it matter if it's a time series? Why do I have time range and filters? The mapper function creates an isomorphic representation of this. So it takes all the filters, put them inside the filters. There's a filter object, and the filter can be a having, can be a where, right? Depending on what is it's being applied. So to implement semantic layers, we have this interface on the right. So we have metrics, dimensions, filters, order, limit, offset, and a group limit. So these are concepts that somebody who's working with semantic layers, they understand. They don't need to learn all the details about how superset works. They look at this and they say, cool, I know what all these things are, right? There's very little context that is needed to implement this. Yeah, so this is the implementation, and these are like the core methods. There's not a lot of hidden stuff here. There's some attributes that are not shown. But a semantic layer, you define it from a configuration, and then you basically have two methods to get semantic views or get a specific semantic view. And then the semantic view has a UID, but then you have like methods that get dimensions, get metrics. What are the dimensions and metrics? It has this interesting concept that doesn't apply to datasets. When you select a metric, not all dimensions might be compatible. So we have a get compatible dimensions, get compatible metrics. This shows up in some semantic layers, and it gives a nice experience exploring. And then we're done with JSON. We're done with pandas data frames. It returns a arrow table. Internally, it's still converted to pandas because Superset expects that. But like, there's the payload is just an arrow table. There were a few challenges. Databases are heterogeneous, like the terminology, the way they're configured. Semantic layers, even more. Here we have an example of a problem we had with databases. So not semantic layers yet. This was a couple years ago. We wanted to add support for catalog to databases. And by catalog, I mean the hierarchy above a schema, right? So your database might have catalogs, your catalogs have schemas, your schemas have tables. BigQuery calls this a project, Snowflake calls it a database, Presto is going to call it a catalog, that's the ANSI SQL name. So before, when you connected to a database, you had to choose a catalog, and people using BigQuery and Snowflake, they were complaining, and they were like, hey, if I want to connect to two projects, I need to create two database connections. That doesn't make sense, right? So we wanted to add an option to allow changing the catalog so that when you're adding a data set or you're in SQL Lab, you have another hierarchy. This was a major refactoring. It took us months. I think it was like 11 PRs, some of them touching 70 files. And at the end of the work, all we had to show was a checkbox and a drop down that sometimes would show up depending on your database. But like, it was a major refactoring that I had to do behind the scenes because nowhere in the code we contemplated that, hey, we're going to connect to a different catalog. SQL Alchemy doesn't support catalogs, so we had to have our own abstraction. But it was a big problem. Now, when you think of semantic layers, it's even more complicated because semantic layers, some of them you might connect to a GitHub repo, some of them have an API request. Snowflake, you connect using SQL. So we're like DBT, you choose a project and an environment and a job. So it's like, it's much more diverse, right? So the solution we did to try to future-proof semantic layers is semantic layer defines a schema. It's just a Pydantic schema that gets translated to JSON schema. And that builds the UI. So if you're adding a new semantic layer, you don't need to write any front-end code. You just define the schema like, hey, this is what I need to configure my semantic layer, right? If you add a new field, it shows up in the UI, everything just works. And then there's a few tricks that we did that allows a partial configuration that updates that schema. One issue we had, you're connecting to a database, right? Let's say you're connecting to Snowflake as a database. So before semantic layers, you type in your credentials, your account identifier, your role, everything, and then it asks which database you want to connect to, right? And then you need to go to Snowflake and you don't remember the name, so you need to go back to the Snowflake UI and see what databases you have. We added reactivity, so when you define the schema to configure a semantic layer, you can add dependencies between fields. So for example, for Snowflake, which is the first semantic layer preset is going to offer, once you've provided your username and password or a private key, any kind of credential, that information is sent to the backend, and then the backend queries Snowflake, sees which databases are available, and it returns a new schema to power the UI. And then that new schema databases is an enum of valid values, right? So instead of you having to type your database, once you have your credentials, we just give you the list of optional values. Again, you need to write zero front-end code. This is all backend. You define proprietary attributes in the schema that says, hey, database depends on auth, and then there's a method that will receive the auth, and you just return a new schema based on the partial configuration. And then there's also this concept of the runtime schema. It kind of solves the problem of the catalog. When you're adding your semantic layer, you don't need to fill in all the schema. There are parts that are optional. So if I'm adding Snowflake, I might not choose a schema. I might leave it empty, right? So I say, hey, I don't want to choose a schema now. Later, when we go to add a semantic view, which is equivalent of adding a data set, then I will have to give that schema because that's the missing part, right? So this gives that flexibility that we showed in the beginning for catalog. So if we want to allow people to change some parameter when they add the semantic view, we can just leave it blank in the semantic layer, and then we would have that runtime schema, I call it. The implementation, yeah, we did this as extensions. Our first implementation was not extensions, but then extensions became mature enough that it was a big win. We just made them extensions. They can live in separate repos. They are automatically discovered. So they should be easy to develop, maintain, install. You can have a different release cycle. There's one thing that I mentioned. I mentioned like you don't have to write front-end code to build the configuration form. In the future, we want to add it and make that an option. So if you really want like a pixel perfect UI for configuring your semantic layer or your semantic view, you'll be able to add React components to the extension, and then that will be loaded instead of the auto-generated form that is built from the JSON schema. So it gives you the best of both worlds.
Just to interject a little bit, this does mention React components on the slide because I just kind of wanted to jump in and talk about extensions in general. This is something we can do another like live demo on if there's interest, just let us know. But this is happening across the Superset code base piece by piece, is kind of taking built-in things and turning them into extensions kind of like VS Code or whatever else, so you can add or replace core competencies of the product in a very scalable way with common shared interfaces. And that can be front-end stuff, back-end stuff, MCP tools, you name it, it all gets bundled in.
Yeah, Tomo is like a YAML file, just commenting. I think it became a Python standard for like configuration, but it's a more readable YAML. Yeah, and this is an example of how you build an extension. You run Superset extensions bundle. It packs everything in this zip file, and then you just put that zip file in your Superset, and you have access to that semantic layer.
Not just any zip file; it's a supx file or a supx file. That's, yeah, our own custom file extension. That's fine. So, what does this all mean? Thank you, Beto, for walking us through all of it. But this opens up a whole world of possibilities for Superset and preset users as we bring this stuff into maturity and start launching these extensions. So wanted to just go through a bunch of positive consequences of all this work. First off, this opens up the world completely. We can now support any semantic layer. So there's a whole bunch of roadmap to this. Preset has certain semantic layers we want to extend. We're open to contributions in open source on Superset. But right now, as Beto mentioned, Preset's working on the Snowflake Semantic Views implementation and DBT MetricFlow. There's already the built-in pandas reference implementation, but there's a whole bunch of other semantic layers that are out there. This is but a sampling that we have here in the middle column. So if anyone is using those or wants to be using those with Superset, then it's now possible to basically follow the pattern and develop the next semantic layer extension.
Someone asked a question about a semantic layer config for BigQuery.
I don't know how if it's something native. I know BigQuery is involved in Ossie, so I'm assuming they're gonna support that.
Yeah, nor do I. But if they are an Aussie participant, formerly OSI, then they should be following the dance moves that everybody else is following. That's kind of the whole point of standardizing. One thing we didn't talk in great detail about is the dataset editor, aka Superset's semantic layer. I'm sure Beto and Elizabeth can both attest that this thing is kind of a hairball of complications in code that's been very kind of tied into the code base since its inception. One of the goals here is to extract this code and use and build our extension interface around it. If we can get Superset's dataset editor or semantic layer to follow and use and harden the interface that all of the other semantic layer extensions are going to use, then it's kind of an everyone benefits, including Superset itself thing. And the whole point of this also is that the core code base of Superset will shrink as things get removed into their own separately versioned modules that can be supported and have their own issues and release cycles. The whole idea here is that Aussie and everything is standardizing everything that we're doing. So you can now just currently use the superset semantic layer. We're bolting on a bunch more. And what you can do here is migrate potentially between semantic layers. And there might be multiple use cases for that. One would be if you're already using something, I don't want to pick on anyone in particular. I'll just say semantic layer A, but your data engineering team wants to move to semantic layer B. You can now actually set up both of them to be wired into Superset or preset and set up your charts and dashboards. And just like you would swap data set on a chart today, you can now swap between semantic layers and basically rewire your dashboards from your old semantic layer to your new one. So it kind of provides you even like a side-by-side view of the two of them to make sure that everything is apples to apples and that you're not having any misalignments as you move between semantic layers in your implementation.
Question real quick, if I can.
Mhm.
Evan, some folks are asking about when this is going to be released. Is it 6.0, 6.1, 7.0? And also, what does that mean for extensions? Will they be able to use extensions with this? Either
Yes. So extensions as a fundamental playground are already released. They were initially a little bit in 6.0 and then more stably in 6.1, but the extension interfaces are still proliferating around. The extension interface for semantic layers is new and it is not part of 6.1. It's going to be or is, I suppose, on preset since we tend to stay ahead of the open source releases. We have our own QA team that constantly pulls in features and fixes and things. So if you're on preset, you have a very kind of curated experience and it's already possible to do this stuff. On Superset, we're actually in what we call the breaking change window for Superset 7.0 right now, which is wrapping up in a couple of days, I believe. After that, we're going to be stabilizing and cutting the next major release, but it's going to be in 7.0. This is kind of a funny use case here too, is I was talking a little bit about migrating between semantic layers, but it is possible and plausible to use more than one at the same time. This comes with a bit of a yellow flag that if you have multiple semantic layer implementations and you're referring to a metric like, I don't know, number of customers or ARR or something like that, then you might have that metric definition misalignment problem again. And you don't want that. But what I could see a use case for is if you have multiple regions of your business, international kind of disconnected parts of the org with different data stacks. That's a possibility that we could support both. Another one that actually does happen a lot for preset customers is we allow you to spin up multiple instances of Superset as workspaces. And those could be used for, different departments, different regions, different customers, different clients, different operating arms. Like say you work with a bunch of subsidiaries or different cities within your ecosystem of government things, then perhaps each of them has their own data org and different semantic layers in their stack. So you can support many of them all at once. And this is where it gets fun. We're in the land of AI. Once you've cleaned up all of your alignment around metrics and dimensions and everything, and everybody's shaking hands on what means what, which is a hard problem to solve. Then suddenly the AI aspect of your analytics becomes a whole lot easier and a whole lot more reliable. So these semantic layers and semantic views all start to compound. And what's fun about doing stuff with AI in your BI tool, like presets chatbot, preset MCP, superset MCP, all of this stuff, is that your charts and your dashboards also provide another layer of context to these models via the MCP tools. So you can think of your semantic layer almost as like the menu of what's available to the LLMs. But if the LLMs have the ability to view your charts and dashboards, they know what metrics you're already using a whole bunch and what dimensions you're referring to them across. And it's kind of like those are your frequent and recent orders you could think of from that menu. So it already knows kind of where to look. It's going to be more efficient and more reliable in using the things you use most. Then there's the project, the ASF aspect of it. We touched on this a bit, but the whole point of it is that this isn't really too much of a technical implementation of a project. It's not like a software thing you download. It is a standard. And the beauty of this is that all these different orgs with different business interests have gotten together. They've all aligned on what these semantic layer definitions are going to be. And the fact that that standard is under the Apache Software Foundation means that the licensing is locked in forever. The governance is there. No single org will ever own this thing. It will never be taken away from you. Kind of like nobody's going to suddenly like grab the wheel and start steering the ship in some weird direction as a very big software organization or whatever it is. It's going to stay this way. Everybody has a voice. It's democratized and it's going to be here forever. So now it's safe to use it. All of this can be standardized into explorables that Beto was telling you about by a single shape of definition. The Ossie project provides a YAML file or a YAML shape, I guess you'd say, that standardizes all of the implementations of any semantic layer. So in theory, if more and more and more semantic layers start to proliferate in the universe and they become part of the Ossie project, they all would be implemented in much the same way. And it really means that these extensions that you can build on Superset could basically be AI'd in a short amount of time. Of course, they need testing and validation and all of this stuff. You want to make sure they're good, but it's all possible. And then I think, Beto, you mentioned there was something besides the YAML definition. There was also potentially like an API spec or something.
Yeah, I think so. The YAML definition allows you to represent the semantics from a semantic layer, let's say Snowflake, as YAML. So it's an intermediary format. And the idea is like you want to migrate from Snowflake to dbt, you export your Snowflake semantic layer to YAML, and then you can import it in dbt. So there are tools to export and import. We could use that YAML as like, we could write a semantic layer extension that reads that YAML and then builds the queries and sends it to the database. But one of the working groups in Apache Ossie is about having an API, right? A standard API to query different semantic layers also. I think that would be the biggest win for Superset, because then we just need to implement a semantic layer that talks to that API, and then all the vendors need to implement that API, and you can just switch from one semantic layer to the other just by reconfiguring the extension.
Now the Ossie project is new. It's still in the incubator program, which in ASF terms means going through a bunch of official steps to make sure it's ready for the world and ready to last forever under its own governance with its own PMC and all of this stuff. So it's getting close. Now here's where you come in. On Superset, we always welcome contributions. So if you want to start implementing these extensions or any other extensions for any parts of Superset, we would welcome you to join us in the Slack room called Project Extensions, and we can go into all of the details on semantic layers and other bits of the UI. If you're a preset user, talk to our team. If you're interested in not running Superset on your own anymore and having all of those hassles and want to start getting some of this stuff, then talk to our team and we can help you get all of the semantic layer extensions and everything else that you'll need to be successful. And of course, if you want to get involved in ASF stuff or already are involved in Superset, then you can also join the Ossie project now. They would love to hear more from you. So we'll start to open up the floor here, but if you are a Superset user, go ahead and turn on the feature flag if you're running off latest master or when 7.0 comes out in the nearest future. Again, if you're a preset customer or want to learn more about these multiple workspaces we're talking about and all of that stuff, then just go to preset.io and reach out. But thank you, Beto, for walking us through it. Thank you, Elizabeth, for fielding
Yeah,
questions. And I guess now we can
thank you
jump
both.
into some of them if we have some.
Yeah, we do have quite a few questions. So
Cool.
yeah, let's get into them. So first question is, how can we use this feature with Databricks workspaces?
I think we need an extension for Databricks. I'm also not super familiar with Databricks Semantic Layer.
I'm
But
wondering if it has to do with Unity Catalog, perhaps?
I assume so, yeah.
Yeah, that's all I've heard it mentioned is Databricks via Unity Catalog, and it seems like it should be a candidate.
Yeah. And like I think like one thing I wanted to mention for semantic layers is like there's basically like two benefits, right? There's a immediate one that okay, now you can connect to semantic layers. That's the benefit. But I think there's a huge benefit in the reorganization we did, the simplified interfaces. Because adding a new semantic layer should be really straightforward. So like if anybody wants to like you can use AI, get the Databricks API for semantic layer, give it the interface, and AI will write the extension for you.
And then someone else did ask about API, and which we already touched on. If I can find it. Will the semantic layer also allow API-based data sources? And the answer on that one was yes. Right? Not sure if you wanted to, if Ossie did extend the YAML to API, right?
Yeah.
Okay, great. Maybe we could talk a bit about caching efficiency. So one question did come up specifically, what the best practices would be for cache efficiency with highly dynamic RLS.
Yeah, that's one thing. Like semantic layers, they don't support RLS today. I mean, it's just because it's a long tail of features to get feature parity with datasets. There's nothing preventing us from adding RLS to semantic view, semantic layers. But like speaking of caching, going back to what I said, like one PR I have open is for a semantic caching. Like now that we have a simplified query like object request, it's easier to like one problem we have with current cache is like you need to do an identic chart to hit the cache. If you're looking at like a metric by country, we cache it, and then you say, oh, actually, I want to exclude the US. We need to run the query again. Even though you could read from the cache, strip that country and reuse the payload, right? So I have a PR open, adding a semantic cache that is able to apply filters on cache payloads and roll up dimensions if they're additive. So semantic layers will open the potential for these kind of optimizations. For highly dynamic RLS, like, I mean, this is something that could be explored, but I think it's a bit risky. But like, you can imagine like caching a non-RLS payload, and when a request with RLS comes, you apply that RLS to the cache payload to optimize a little bit. It needs to be well thought because it involves security, but I think it would be possible.
Maybe one more question. We do talk a lot about the performance of queries. So if someone's asking, I won't read the whole thing, but generally, what do we do about predicate pushdown times when you've got a time filter on the end of a query? Will semantic layers help here?
I think it will help because the query generation, I have another PR open that I want to address soon that is rewriting the superset semantic layer as an extension. That eliminates like 5,000 lines of code, simplifies the code flow a lot, and it really simplifies the query generation. It uses SQL to generate the query. Today, the way we build queries is we build a SQL Alchemy query object, and then we transfile that to the dialect. With the reimplementation of the superset original semantic layer as an extension, I'm using SQL because we started to use it heavily. SQL support predicate pushdown. So I think once we have the native superset extension, then it should be easy to do optimizations like that. There is I don't know. I don't remember if this is preset only, but there is a comment you can put on the query to do predicate pushdown. Is that preset only, Elizabeth?
If you use the DB mutator and the config,
Yeah.
you can by using SQL So the preset one with the comment is something that you could kind of build in if you wanted to through the DB mutator.
Yeah. Because SQL supports predicate pushdown, so you could write a secret mutator that does that.
Yeah.
If you want to do it today.
One more question. Last one. How can people get more information, documentation on how to do this? And do they need to build an extension, or is it something they could just write a little something to make it work?
We don't have a work group for semantic layers. We've been kind of leveraging this extensions work group. Yeah, but to leverage this, either someone has to have written an extension for your semantic layer, or you have to write it. Again, I don't think writing an extension is scary as it sounds. Like if you have a semantic layer, you want to give it a try. If you're using a semantic layer, I would suggest giving it a try.
Yeah, there is generalized documentation about writing extensions on the Superset website in the developer docs section. You can check that out, or your agent can check it out, whoever's implementing stuff. But also, I'm going to be publishing a blog post about a lot of this, and we can go into some of those details there. So hopefully I'll have that up in the next day or two, and we'll send that out perhaps along with the YouTube link for anyone that needs to see it, so you can have some extra details here. But also on the Superset site, there's a community calendar, and that has a link to the extensions working group. If you want to join to build semantic layer extensions or any other kind of extension into Superset, then come on in. We could use all the volunteers we can get.
And soon you'll be able to use them with preset, right? I'm not sure about the release dates, but
there was a question about when those could be built, and we're kind of in the middle region. I think that 7.0 is the official release that will support them. On the preset side, we're ahead of that, but you can fiddle around on master as of right now.
Yeah.
Maybe we could touch again on how semantic layers will be supported in preset versus superset. I think you talked a bit about it, that preset will be releasing Snowflake, DBT Cube over the next few months. The foundational work is in Superset, but might require a little bit more configuration, building a small extension. But you should be able to, of course, add more if those three don't cover your use cases for you. But we'll be continuing to roll out different semantic layers in Preset as well, if you want to wait.
And if anyone watching this is a preset customer and you need support for something, please ping us. Let's talk. Thank you all for joining us. If you do have questions, by all means, reach out either on community channels, the Superset Slack, or reach out to Preset, and we'll be happy to help you in the future with implementing all of this stuff and releasing it. And we have a lot more features coming out in Superset 7.0 and in our upcoming preset releases. So you can also join the calendar to come to more of these events. So we'll see you next time. Thank you for joining us. Thank you, Beto. Thank you, Elizabeth. And thanks everybody for coming.
Yeah. Everyone, thank you, Evan. Good to see you, Elizabeth.
Yeah, bye.